All right, so let's look at our second example. And again, I'll give you an easy sample size because we're only working with 100 patients. The new treatment for cancer has proven effective 72% of the time. If this treatment is given to 100 patients, can we use a normal model to approximate the binomial distribution? So first of all, we want to ask ourselves, is it binomial? Well, P represents whether or not it works. So that's 72% chance that the treatment works, which means there is a 28% chance that it doesn't work. So those are the only two outcomes. And I think you can see that out of 100 people, 72 of them would recover and 28 of them would not recover. So that satisfies the second condition, which means the success and failure of our sample, success and failure is greater than 5. So if we check n times p and n times q, n times p is 72 and n times q is 28. These are greater than 5, right? So we're good to use a normal model. So our mean in this case is going to be 72, and our standard deviation is going to be 0.72 times 0.28 times 100. So let's go back, second square root, 0.72 times 0.28 times 100. And we get 4.49, we'll just say 4.5. So I get mu is 72, and theta is 4.5. So if we set up our distribution here, we know the mean, it's going to be normally distributed with a mean of 72 and a standard deviation of 4.5. So if we look at this model for a question, what is the probability that at least 75 people will be helped by the treatment? So at least means 75 or more. So we want to know what's the probability that the number of people helped is greater than 75. So that is going to be normal CDF from 75 to 100, and the mean is 72 and the standard deviation is 4.5. So we go to our calculator, see if I can remember all that. So it's going to be 75 people to 100 are helped, and the mean is 72 and the standard deviation is 4.5. So 0.2025. Waiting for my computer to come back. Slow Wi-Fi. Well, I hope you guys are taking care of yourself during your vacation, or this, not really vacation, but during this break. Hope everything works out. 0.2525, I know it will. So it's a 25.25% chance of that happening. So if we looked at this in terms of the model, 72 goes in the middle, and 75 was to the right. So it was not quite one standard deviation away. So to the right of that's going to be around 25%. Excuse me. And we could ask the same question. What is the probability that 50 or fewer people will be helped by the treatment? Again, if we look at the model, 72 is here, 50 is going to be way down here. Not a very good chance of that occurring. So the probability that less than 50 people will be helped. Again, it's going to be normal CDF from 0 up to 50 people. And the chances of that happening are very slim. So from 0 to 50, from 0 to 50, and 72, and 4.5. So that's 5 times 10 to the negative 7. So that is basically 0. 5 times 10 to the negative 7th is basically 0.000001234565, which is basically 0% chance of that happening, right? So let's see how many more examples. We're going to do one more example in this section, and then I'll do the next video. The probability that less than 20 people will not respond to the treatment is a little tricky here. What I'm asking you is, what's the probability that Q will happen? So we're going to look at the same model, but for this model, the mean number of people that don't respond is actually 28, and the standard deviation stays the same. So we want to know that less than 20 people will not respond, that X is less than 20. The only thing that changes here is for a normal CDF, it's 0 to 20, but the average number of people that don't respond is 28, and it's 3.36. So 0 to 20, so 0 to 20, and the average number of people that don't respond are 28, and that's 3.36. 0.008, so about a less than 1% chance of that happening. So that's 0.008, which is a 0.8% chance of that happening. All right.